Okay, let's look at some features on our calculator. Previously, we looked at how we could use the F2 menu of the TI-89 to solve these equations, to factor expressions. That's all here from the previous uh, show. Okay. Again, if we want, we can review that again. Maybe I want to clear my screen. That's option 8. Clear it all. So I have a and clear that again. Remember now what we did was we simply said F2 and we could say solve. All right, and I'll take that option 1, enter that, okay, and then solve. Let's say we solve this second equation. That's x to the 4th power, okay, minus 5x squared minus 5x squared, okay, plus 4, and that's going to be set equal to 0. That's what the equation reads. Set equal to 0, and we're solving that for x, okay? So that now, the TI-89 will tell us that that is, the solutions of that are 2, -2, 1, and -1. They are reported up here as you can see, okay? Scroll on over and you see all the solutions. Now, okay, some of you are concerned because your calculator, if it's not a TI-89, does not have this feature, okay? Well, so that's what we want to show you, techniques that you can use on your calculator, okay, that might mimic this for you, okay? And so we're going to look at both of these in terms of their graphs, okay? Now, and all of you have a graphic calculator, so you can apply this to whatever calculator you have, as long as it's graphic, okay? Now, to go to the graph, our graph menu is up here. It's a green function, therefore we activate it by diamond F3. It takes us to this. Of course, I have something in there, a sine graph. What I want to do is I want to go to my y equals. Let's back that up again. Let's go back to the home screen. Okay, I want to graph something. So I can go right to diamond F1 where I put in what I want to see. Okay? I want to see the line y equals x. Okay, so I'll just go down here, I'll clear that, and I'll put in y equals x. Okay, come and see that. Now we look at the graph, diamond F3, and okay, you might say, well, maybe that's not what you're seeing. This is what I'm showing, because my window, okay, my window here, diamond F7 or F2, okay, if you simply choose the option zoom to the standard window, okay, which is down here as option 6, then you'll see y equals x, okay? Quite simply, y equals x, all right? Okay, you may not have to do that. It's a good feature to have. No zoom standard. Sometimes you might want to zoom in, zoom out. We'll go over that later, okay? But right now, you'll opt for zoom standard, okay, option 6, to give you what effectively is a window spanning 10 units in x, 10 units in y, in positive and negative direction. To see that, you could go to the F2 menu with the diamond F2, which tells you the minimum value of the x-axis, -10, maximum x value is 10, the y minimum is -10, the y max is +10. Okay, and it's in units of 1 unit. That's the scale. Okay, so that's what your graph looks like. Now, how do we interpret, okay, the solution to this equation by means of the graph? Well, let's put it in and see if you can figure it out. Okay, so again, we're going to alter this equation, x to the power 3, okay, minus 9x, and we're going to ask for the picture of that, okay, just to see if you can correlate. There's the picture of that, okay. the picture of that, as you can see, and we'll discuss how you get the picture of that without the calculator later, but notice 1, 2, 3 places where it crosses the x-axis. When it crosses the x-axis, the y is 0. If the y value here is 0, then we effectively have this equation. So, the conclusion, the solutions to an equation and a polynomial equation of this sort can have up to this many, 3 solutions. Come down here, up to 4 solutions. It may not have all 3. It may not have all 4. It may have no solutions. But it will have a maximum number of solutions indicative by the highest exponent. And those solutions from the graph are merely the x-intercepts of the graph. So this intercepts at -3, this intersects at 0, that intersects at +3. Okay? So there you have it. There's a connection. If we go now, okay, y equals, in this time around, I'm going to graph the second one as a y2. Okay, so that's y, I'm sorry, go back, that's x to the 4th power, let's see, minus 5x squared, 5x to the power 2, plus 4. Now we're going to ask to graph that. Now the problem is it's going to graph both of them, but we have an option here. See next to y1, y2, we have a little check mark. Okay, that's toggled on and off, which will turn off the picture of y1 or y2 by the F4 command. So I want to go up to the y1 actually, and I'm going to toggle F4 so there's no check mark here, meaning I will not see this picture. I will only see this picture. Okay, so off we go. If all is correct, the graph of y equals x4 minus 5x squared plus 4 will tell me the solutions to this equation, because from the graph, if y is equal to 0, that means we're finding the x-intercepts of the graph. So here we go. The x-intercepts of the graph are synonymous with the solutions of the equation set equal to 0. There you have it. Okay? There you have -1, -2, +1, +2. Now, you should be suspicious. How do I know that that's exactly 1? How do I know that that's exactly 2? In the next video, we'll discuss how you can find definitively something of this sort. Of course, you don't need the calculator, okay? Because you can factor it. But in some cases, like I said, you got to be, you want to know that that's exactly, okay, crossing at 1 and 2. And we'll go through that in the next video. But for now, the solutions to a polynomial equation will be at max the number of solutions matching the highest exponent. Now, some of those are real, some of those are imaginary, perhaps. In this case, they're all real. The cubic expression, 3 real solutions. The 4th power expression, 4 solutions. Okay? That's a fundamental theorem of algebra. The number of solutions corresponds to the highest exponents in a polynomial expression, a polynomial equation. Graphically, the solutions to that occur in the graph when y equals 0, which is the crossing, the x-intercepts of what will be what we call the function later. Good to know. You can always find the intercepts from a graphical standpoint. In the future, when we want to graph this, we're going to factor this to find where the intercepts are, and then have some notion that we have to go through those intercepts, but with the shape, that will be discussed later. Okay? So there's your lesson for today.